with a topic on seafloor spreading and plate tectonic theory. This is week number 6, day number 3. At the end of the learning episode, you are expected to: number 1, analyze how seafloor spreading theory spreads outward from the underwater ridges and how it contributes on the unifying continental drift theory. Number 2, discover how reverse magnetic field of the Earth took place and explain plate tectonic theory as a unifying theory. And number 3, appreciate evidences of seafloor spreading with the ages of rocks and the unifying continental drift theory. Before we start, let's answer a few questions. Analyze the following questions and you choose the best answer. I will give you 3 seconds to think of your answer. Number 1. In seafloor spreading, molten material rises from the mantle and erupts blank. A. Along mid-ocean ridges. B. In deep ocean trenches. C. At the north and south poles. D. Along the edges of all the continents. What's your answer? The answer is letter A. Number 2. Mid-ocean ridges are blank. A. Long deep ocean trenches. B. Found in all of Earth's oceans. C. Found only in the Pacific Ocean. D. Located mostly along coastlines. What is your answer? The answer is B. Found in all of Earth's ocean. Number 3. How did scientists discover that rocks farther away from the mid-ocean ridge were older than those near it? A. By determining the age of rock samples obtained by drilling on the seafloor. B. By observing eruptions of molten material on the seafloor. C. By measuring how fast seafloor spreading occurs. D. By mapping rocks on the seafloor using sonar. Think of your answer. The answer is letter A. Number 4. Old oceanic crust is denser than new oceanic crust because it is blank. A. Cool. B. Hot. C. Spreading away from the ridge. D. Moving toward a deep ocean trench. What's your answer? The answer is letter A. Cool. Question number 5. It is a device or a pack used to provide a person with essential supplies during an emergency. A. Groceries. B. Beauty kit. C. Radio and other devices. D. Survival emergency kit. Think of your answer. The answer is letter D. Survival emergency kit. Don't worry, students, if you failed to get all the correct answer. Listen carefully on our discussion. In your previous lesson, you have learned the continental drift theory of Alfred Wegener. You're going to answer the following questions with true or false. Identify if the underlined word makes the statement right or wrong. Number 1. Wegener thought all the continents were once joined together. Is this true or false? Yes, the answer is true. Number 2. Harry Hess became the father of continental drift, supporting evidence that the continents move over time. Is this true or false? The answer is false because the underlined word must be Alfred Wegener. Number 3. Wegener's continental drift theory was accepted. It did not introduce the idea of moving continents to geoscience. Is this true or false? Yes, the answer is false. It must be discarded. Number 4. Scientists would confirm that some of Wegener's ideas, such as the past existence of a supercontinent joining all the world's land masses as one. Is this true or false? Yes, the answer is true. Number 5. Pangaea was a supercontinent that formed roughly 200 to 250 million years ago. Is this true or false? Yes, you're right. The answer is true. I hope you get all the correct answers. It's good to know that you still remember our previous lesson. Let's discuss. Where was the last time you go to the beach? What are the things you do on the beach? Look at the pictures. How would you describe the view? Isn't it refreshing? It's the sea. Let us analyze how seafloor spreading happens. Seafloor spreading, a theory of lithospheric evolution that holds the ocean floors are spreading outward from vast underwater ridges. First proposed in the early 1960s by the American geologist Harry H. Hess, its major tenets gave great support to the theory of continental drift and provided a conceptual base for the development of plate tectonics. How did Harry Hess discover seafloor spreading? Harry Hammond Hess envisaged that oceans grew from their centers, with molten material like, for example, the basalt, oozing up from the Earth's mantle along the mid-ocean ridges. This created new seafloor, which then spread away from the ridge in both directions. What is seafloor spreading? It is a theory that oceanic crust forms along submarine mountain zones, known collectively as the mid-ocean ridge system, and spreads out laterally away from them. According to this theory, the seafloor or ocean floors are the ones moving, carrying the continents with it, just like the divergent boundaries. These are the three types of evidences found for seafloor spreading. Number 1 is the evidence from ocean material. Rock shaped like pillows only form when molten material hardens quickly after erupting underwater. The second one is the evidence from magnetic stripes. As the molten material hardens, magnetic minerals inside the rock line up in the direction of the Earth's magnetic poles. This forms unseen magnetic stripes, and the magnetic poles reverse themselves. The stripes are mirror images on each side of a mid-ocean ridge. Number 3. Evidence from drilling samples. Youngest rocks found near mid-ocean ridges, while oldest rocks found far away from mid-ocean ridges. The magnetic reversal is also called magnetic flip of the Earth. It happens when the north is transformed into the south and the south pole becomes the north pole due to a change in the direction of the flow in the outer core. Let's watch a short video to discuss about this.
Hi everyone. We're going to talk about the Earth's magnetic field and how the reversals in the Earth's magnetic field revealed that seafloor spreading is happening. The Earth's magnetic field creates lines of invisible force that you can't see, but that your compass needle senses. And the reason your needle points north is that these field lines emerge from the south magnetic pole and wrap around and point toward the north magnetic pole. Now, we know that the Earth's magnetic field has actually reversed, flipped around, so that these arrows would all point the other direction, coming out of the north and pointing into the south pole. And these are called magnetic reversals. They happen every few million years. The Earth's magnetic field flips back and forth through time. The reason we know this is that lava flows, like this lava flow on Hawaii, when lava flows out of the Earth, it actually, there's little magnetic minerals in the lava, and they line up with the magnetic field at the time and actually preserve, like a tape recorder, the direction of the Earth's magnetic field, whichever way it was pointing, either normal or reversed. So if we go look at a whole series of lava flows, what we'll find if we sample through the lava layers into older and older layers, we'll find some layers that are oriented with a magnetic field, say like today, and other layers, older layers that are reversed, and then still older layers that are like today. So through geologic time, the Earth's magnetic field flips back and forth, and we call these magnetic polarity reversals. Now, the way that this all relates to seafloor spreading can be realized by remembering that lava is pouring out of the Earth at mid-ocean ridges. Okay, so I want you to imagine that we're going to let this ocean basin spread, and we're going to let the Earth's magnetic field flip back and forth as the ocean basin spreads. Remember that when the lava erupts and cools down, it records the direction of the magnetic field at the time, whether it's normal or reversed, backwards or forwards. So we'll start the animation here. We're going to start it at a time when the Earth's magnetic field is like today, what we call normal polarity. And as the seafloor spreads, it's all going to get polarized in the direction of the magnetic field, shown by the blue part of the ocean floor. But now we have a reversal happening, and any new lava that erupts is going to get magnetized in the opposite direction. So you can see the little compass needles here have flipped, showing us that all this new seafloor is recording the direction of the Earth's magnetic field at a time when it was reversed. Now we'll let the Earth's polarity flip again. Any new lava that forms is going to record the polarity of the Earth at that time. So what we see on the mid-ocean ridges of the world today is a series of stripes, symmetrical stripes on both sides of the ridges of seafloor rock that's magnetized in the same direction as the magnetic field today, older rock that's reversed, still older rock that's back to normal. This pattern is impossible to explain if seafloor spreading didn't actually happen and the Earth's magnetic field didn't flip back and forth. So it constitutes some of the best evidence we have that the seafloor is actually spreading over geologic time.
Here are the evidences of the plate tectonic theory. Number 1 is paleomagnetism. It states that rock-containing iron-rich minerals are magnetized and it points toward the magnetic pole. The strips of alternating polarity occur at ocean floor or seafloor spreading. The second one is the earthquake patterns. It tells about the shallow focus earthquakes occur within the trench where descending plates interact with lithosphere, and the deep focus earthquakes occur toward mainland when oceanic lithosphere plunges into the mantle. The third part is the ocean drilling. Ocean drilling it is when sediments closer to the ridges will be younger, while sediments farther away will be older. The youngest oceanic crust is the ridge crest. The fourth one is the hot spots. It is an area in the mantle from which heat rises as a thermal plume from deep in the earth. Plate move, creating successive volcanic mountains and chains. Hey, it's activity time. You are going to answer the activity sheets. For activity number 1, you had match me. You are going to match column A with that figure on column B. For activity number 2, split and separate, you're going to prepare for a simple representation of the seafloor spreading. Happy learning! For our activity 3, you answer this with be safe. You're going to put a check if the following material should be put inside your emergency kit. Good luck in answering our 3 activities. Using the diagram, fill in the 4 rectangular callouts to the left with words related to, and you've learned from the word seafloor, and the other 4 rectangular callouts to the right of the words learned from plate tectonic theory. Good luck in answering! And our country, Philippines, is situated on the Pacific Ring of Fire. That is why we are vulnerable to calamities like typhoons, earthquake, flash flood, volcanic eruption, and even viruses that kill thousands of lives. It is important that we are all prepared on all the calamities that comes around us. You're going to answer this activity number 3 on your activity sheets. As you can see on the figure, we had the survival emergency kit that is necessary in case of emergencies. It is a device or a pack used to provide a person with essential supplies during an emergency. So what is inside in my emergency kit? Answer this on your activity sheets. Let's proceed now with our pause test. Number 1. Usually, old rocks are found blank. A. Near the ridge. B. Far away from the ridge. C. At the center of the ridge. D. At the side of the ridge. Think of your answer. The answer is letter B. Now, number 2. It states the rocks containing iron-rich minerals are magnetized and it points towards the magnetic pole. A. Earthquake pattern. B. Hot spots. C. Ocean drilling. D. Paleomagnetism. Yes, the answer is D. Number 3. It tells about the shallow focus earthquakes occur within blank, where descending plates interacts with lithosphere, and the deep focus earthquakes occur toward blank, when oceanic lithosphere plunges into the mantle. A. Mantle and crust. B. Hot spots ridges. C. Trench mainland. D. Plates boundaries. Think of your answer. The answer is C. Trench mainland. Question number 4. How does the seafloor spreading becomes evidence from drilling samples? Determine the age of rocks. A. Youngest rocks found near mid-ocean ridges, while oldest rock found far away from mid-ocean ridges. B. The rocks on the ocean floor moves away from the ridges, becoming rocks older. C. The younger rocks are hard to find, while older rocks are seen on the seashore. D. Rocks are determined by means of its color and shapes. The answer is A. Number 5. It is an important thing to do to avoid diseases. A. Wash hands as needed. B. Touch your face. C. Limit the intake of water. Or D. Forget wearing mask. What's your answer? Yes, that is letter A. Wash hands as needed. Congratulations! I hope you get all the correct answers. Keep safe everyone. Keep up the good work.